Good morning, everybody. Welcome to NTWC Plus for the 13th day of November. Good to have you along. Thanks, Alex, for the introduction. Good to see everybody this morning. Getting close to the end of the season, ever so close to the end of the season, but it's not going quietly. It sounds like this season is going to finish on a high note, probably. More about that in just a little bit. Jonathan Zawislak, you'll have to say it properly for us in just a little while, is our guest a little bit. I think it's going to be a fascinating conversation today, talking more about flying into the storm and everything that goes into making that happen. We'll get to that in just a little bit. Bill Reed is back from his cruise halfway around the world. Good morning, Bill, and welcome home.
Hey, thank you, Tim. It is good to be home. The dogs appreciate getting out of the kennel, and we're back into the normal swing of things here in League City, Texas.
Tell me a little bit about this cruise, because this was not your normal, travel at night, port by day, travel at night, port by day. This was a little different, wasn't it?
Yeah, I managed to get, there's a longer story we don't have the time to go into, but without actually looking for a gig like this, the company called Sea Dream offered me a lecture series on Sea Dream 1 for an Atlantic crossing back to the Caribbean from Spain. So that's what I was there for, and of course they pay for your cruise and all that for that. So it was an opportunity I couldn't resist, because normally I hadn't been thinking about doing a crossing before. I like going on cruises, but that's how that started. If you remember, a couple of weeks ago there was some really disastrous flash floods over in the Valencia state of Spain. We set sail about as that storm was organizing over the general area of Iberia down into Morocco. It got cut off, and that's part of the reason the floods occurred there. And behind it, to the west of it on the block, was this huge high pressure, about a 1038 center out to the west of the Azores. And once we popped out in the Atlantic, we were in the long fetch from almost to Iceland down to where we were, and the seas got very rough up to the swells were running 6 to 7 meters for the first 36 hours. Fairly small ship we were on. Virtually all of the passengers, including yours truly, were seasick, and about 60% of the crew. The second day it was a little bit better. The wind had dropped off some, so we didn't have the chaotic seas. And then we put into port at Madeira, which was an interesting stop. And from there, the rest of the way, we had tolerable weather. We had pretty good swells, but they were on long periods, so it wasn't as drastic. And as far as I know, most of us got our sea legs by then, and seasickness wasn't an issue. Beautiful weather, lots of rainbows when we got into the tropics, and before we got to St. Martin, our terminus, we were in probably a part of the seedling that's going to become Sarah here in a couple of days. So it was a couple hundred miles to the east of the islands at that time. And the cherry on top was the day we were going to put into port. A water spout formed less than a mile from the ship. Very photogenic, so that was cool. That was the cruise.
What a trip. That's a lot of time at sea without stops. How long were you from, I guess, Madeira to St. Martin without a stop? How many days was that?
12.
Wow. That's a long time at sea. So that's not what this program's about today, but I'm just curious about it. What'd you do all day when you're on a ship?
Well, I had to give 6 lectures, so it's not the typical audience I'm used to speaking to. So I had to at least review what I'd put together before the trip, and that led to a lot of people were interested. There are always people interested in weather, so they got you captured. You can't walk away and go home. Now you got to answer their tough questions. But you're answering the tough questions over a glass of wine or a scotch and water, so it's not all bad. And things like that. Got to go up to the bridge, it's that kind of thing, and see it's all under glass. It was all very modern what they have on the bridge for navigation. Their primary app that they follow for keep up with the weather is windy.com, interestingly enough. It's only a 2-ship operation, and they do not have as far as I know, they don't have a contract with any consulting firm to give them a value-added forecast for their trip there. And
They don't have a Craig Setzer like one of the cruise lines does. That's all he does.
and at least for this cruise, the captain was very savvy when it came to weather. He knew exactly what was coming up, and I made a game out of comparing what I thought the seas were, and then he'd give his spiel around noon as to the weather conditions in the seas, and we were usually very close.
That's awesome. That's awesome.
I was a little lower than him, and I'll take his experience over my lag of 50 years of not doing that.
I'm sure it can be arranged. You could do this every fall if you'd like, be part of that.
Well, if they want me again, I'll probably do it the other way, go from the Caribbean back to the Mediterranean somewhere, and then take a few days to a week exploring wherever we end up. That's kind of what Donna and I were thinking would be a nice way to do it again.
Well, Jonathan and I would join you, but we don't meet the minimum age requirement apparently yet. So we'll get there. We'll get there.
Nope, that's right. You got to be old with a lot of free time.
There you go. Well, we'll get to Jonathan in just a second. I want to thank our sponsors once before we get started today. USAA, the South Padre Island Convention and Visitors Bureau, the Weather Company, Weather Boy and Weather Call, all the folks who make NTWC Plus a possibility, and also, of course, a big part of what we do live on South Padre Island every year during the month of April. We'll be there the first month of April of 2025. We hope you'll join us. A lot of the folks who are on these programs week in and week out will be there as well, so you get a chance to be up close and personal. Small, kind of like Bill's cruise ship. It's a small ship, so you're up close and personal with everybody. That's the way NTWC is. It's a small conference, so you get to have dinner with the speakers and really spend time in the Millibar, get to know everybody. So it's a lot of fun. So, all right, Bill, take it away. Let's meet our speaker and have fun for the day.
Sounds great. That was a good comparison. I would say the congeniality and the making of new friends and reconnecting with old ones fits very close to what the experience on the ship was. Good show. So, bringing around to our guest for today, we have Dr. Jonathan Wislack. I know him as JZ from having met him in the past, and he is currently a meteorologist flight director at NOAA's Aircraft Operations Center, where he plays a big role in the planning and execution of mostly research flight missions flown by the NOAA aircraft in support of both the National Hurricane Center and research interests at NOAA's Hurricane Research Division down in Miami. So welcome, JZ. How are you doing?
Hey, Bill. How are you? Really good. Looks like we've got another storm coming, and it's going to be pretty busy this weekend, early next week, with some more aircraft ops. Fortunately, the hurricane season isn't over.
Yeah. Alex, Tim, and Bill were kind of biting our nails, so we get an email from you saying you're airborne and wouldn't be available today. But I think we beat it by a day. Are you already on the schedule, or is that?
Yeah, we've received our tasking for as early as Friday afternoon from the Hurricane Center, so we'll be planning some pretty decent tempo of ops as the storm develops. As long as we got to take it. Unfortunately, hopefully, it avoids the U.S. landfall, but of course, I guess we'll talk maybe some models are pointing in that direction. So we'll see, but we'll get the aircraft out there, get the data, and see if we can't make this forecast better and fine-tune that forecast.
Yeah, I'm guessing that the G4 data would be interesting to get a better grip on what the steering might be over the Gulf in a few days. Okay. Why don't we start with describe what your job is there? Because I'm sure a lot of people have no idea what a flight director does.
Yeah, so as a flight director, I'm one of the in-house meteorologists at the Aircraft Operations Center. So we have 10 aircraft here at AOC and NOAA, and they support scientific operations, research, operational missions. We have 3 what we call the heavy aircraft. That's the P3. Those are 4-engine turboprop aircraft. They're the storm-penetrating aircraft. So it's the aircraft we fly right through the eye wall and get that intercore data collection. And then we have the Gulfstream 4, the G4. That's a higher altitude jet. So that kind of flies around the storm. So my job as a meteorologist and flight director is to support the heavy aircraft operations. So our main role is to actually fly on the aircraft. We're the onboard meteorologist expertise, and we work with the flight crew to get the aircraft in and out of the storm environment safely. That's the primary job, safe flying. And then our other job, of course, is to support the science. So we're given the mission requirements, the science requirements, what do the scientists want to get out of the flight, or what the Hurricane Center needs for the hurricane data collection. So our job is to ensure that that scientific data collection happens and that we get quality data off the aircraft. So we're doing a lot of data QC on the aircraft, monitoring the data flow, everything off the airplane. So we'll keep the airplane safe, go get the data, and we come home and do it again as many times as we need to. In the off season, we also do some other projects supporting science. Same thing, keep the airplane safe, supporting the science.
Yep, that's it. We had another one of the players in your job on a couple of weeks ago, Jason Sipple.
I know Jason. Yeah, I saw some of it. I used to be still colleagues with him, but I used to work directly with him as a researcher at the Hurricane Research Division. Kind of unique role. I went from research to supporting research on the aircraft.
Yeah. Which one's more fun?
You know, they both have their benefits. You know, I love that research, you know, not knowing what the actual answer is and doing the discovery, but I'd say I've always been fascinated with data collection. And I think it's kind of a science in itself, is how you actually collect data. So my fascination moved to here, and I love flying. I love flying. And so I certainly cannot complain. I'm living the dream here, flying for scientists. And I do miss doing that research. I don't miss the coding, perhaps, or maybe the long nights of writing papers, but that's the benefit.
Okay, yeah, you get the taste of all the worlds there. Who knows? Maybe you'll end up at NHC someday and make it go full circle in it, because that kind of background would certainly work well there. But so, what has been your most interesting storm to date?
Well, I've been doing this. I mean, I've been on the aircraft for 9 years now. This is my 9th hurricane season. So I did 7 as a researcher doing the data collection effort. And now I've been here at AOC as a flight director for a couple seasons. I will always say that, you know, the big ones are the Cat 5s, right? Those are the kind of the most exciting to me, because the storm's big. The airplane's doing things you never expected an airplane to be able to do. It does it well. But certainly you feel motions you never thought you'd feel. And but for me, obviously, scientifically, the coolness factor of seeing the stadium effect is it's memorable, it's beautiful, it's chaotic, it's everything you could ever think of. And I always said, for those storm chasers seeing tornadoes, that's fine, but come up and see a stadium effect Cat 5. That's pretty remarkable. So been 5 Cat 5s and just 2 this year, Burl and Milton. Milton being probably kind of the most interesting to me, because I was on the crew and I was a flight director for the crew that measured the sub 900 millibar pressure and when it was out there in the Bay of Campeche.
Yeah, when I was flying, we didn't have a single storm that had one of those what we call pinhole eyes. So I didn't have I don't have anything to really compare to that. What is the turbulence worse in the ones with the pinhole eye than a broader hurricane?
You know, it really varies, and I gotta say, like the Milton, I briefed some obviously pretty severe turbulence. We were expecting a pinhole eye, and I briefed the flight crew that, you know, that tends to be pretty vigorous. The updrafts, you're hitting your gradients a lot quicker, so the wind's coming down really quick through the eye wall. But honestly, the turbulence actually wasn't that bad in Milton, at least to what we were expecting to get in Cat 5 Milton. Some of the worst turbulence I can recall from most of the flying that I've done has been landfalling flights. You get that shear starting to kind of move the vortex up, and, you know, tilt the vortex. We get these what we call scallops. It's the radar signature, where you kind of the back end, you start seeing these little fingers coming into the eye wall. Those can be some of the worst turbulence I get. You get a lot of side motion in addition to the up and down motion. And RI storms, we always pretty much brief severe bumps, continuous moderate turbulence on those RI storms, just because you're getting the strongest vertical motion, the strongest motions in those RI storms. The center is tilting with height. It's trying to organize. Anytime a storm is organizing, whether up or down, it tends to be the most bumpy. But Milton, I put it maybe a 5 out of 10 in terms of bumpiness.
Fascinating. Yeah. The tail Doppler radar data, I understand you're getting that into the operational folks quicker than in the past. How is that done?
Yeah, I think Jason alluded to it, that It's a game changer. The tail Doppler radar and the P3s, the G4, it's a total game changer. It really what sets us apart from the Air Force Hurricane hunters who don't have that radar, because you're relying a lot more on your flight level data. We get this 3D picture, and so on the aircraft, obviously you need good bandwidth, and we struggle a little bit with bandwidth. It takes me 5 minutes to load a satellite loop, but for the TDR data, it gets off pretty effectively. And so every time we pass through the storm, we're collecting sweeps. So there's a couple antennas on the TDR forward and after the aircraft. And so you do some fancy math, you can combine that into a wind analysis. So it's like simulated Doppler analysis, except you have one radar, but two antennas. So essentially we have HRD does a lot of the work on this quality control into the data. So they'll collect all the sweeps from the pass, from the TDR, put it together, run a QC algorithm on it, and then we'll kind of bundle that package up. And we send off a couple files. One of them is for AWIPS, so that display system in the Weather Service and the Hurricane Center environment, so they can see the slices of the storm, the wind and reflectivity. And then we bundle up the radial velocity data from the TDR to go to the models. So it takes about just under an hour to fly a pass through a storm. So once we do that pass, we end the process. It takes about 45 minutes or so for the whole packaging to happen and get down to the Hurricane Center and get in the model. So that's a pretty good latency to be able to go through a storm and then see the structure of the storm within about 45 minutes of actually going through the center. It's pretty cool.
Oh yeah, when I retired, we got zero back. It was after
right,
it was processed on the ground, but mostly a research mode then. I would suspect that's very useful for analyzing an eye wall replacement cycle, seeing the wind field change when that's getting ready to happen.
Yeah, it really is. And just in Milton alone, we actually have another radar on board. So you do see from TDR, and it takes a little bit of time to kind of, like I said, get that data to the ground, have the Hurricane Center see the structure. We actually have another radar on board called the MMR. That's called a multi-mode radar. That's what MMR stands for. It's on that kind of M&M looking radome on the belly of the P3. And that looks 360 degrees around the aircraft. And we have a couple of modes on it. One's a normal kind of preset mode. You see the reflectivity out in front of you all around the aircraft. But we have another mode called the surface surveillance mode. It's kind of a surface roughness. Think of it like synthetic aperture radar. So it's just a black and white image, but we actually use that to look for secondary eye walls. And in Milton, when we had that sub 900 millibar surface pressure in the center, we actually were also looking at that secondary eye wall that was beginning to develop. And so on our inbound to that eye, we actually passed through the secondary eye wall, and it was very, very distinct. This very nice ring, secondary ring in the returns on the MMR. So it's a pretty cool, unique set of tools to not just have one radar. We have 3 on the aircraft, right? And they all provide different levels of information, different situational awareness, and different levels of data.
Yeah, that is interesting, because you hear a lot about the tail Doppler data, but the belly radars we used to call in the Navy, it's the same looking radar. And we had I forgot what the acronym on it was, but it was a 10 centimeter radar. What is this, a 10 centimeter, or is it?
It's different. So yeah, that was the lower fuselage radar is what we used to call it. It's still in the lower fuselage. It's in the same housing as the old LF. And yeah, the old L one was actually C-band, so it was a little bit larger wavelength, had a little bit less attenuation. The MMR we currently have on the P3s is X-band. So it's a little bit smaller wavelength, which means it attenuates quicker. And for me as a flight director, when I'm trying to get us through the storm, I need to know what's all around me, in addition to be what's maybe, I see the hard rain. I can see the really high intense rain rates, but I need to be able to sail past them as well, because if I'm in the eye wall, I want to know the extent of the rain I have out of the eye wall, say I'm going outbound. Problem with the MMR is X-band, there's a lot more attenuation. So a lot of times when we're in these really strong storms, we have the stadium effect, we got a full ring of intense eye wall, I can't see past the eye wall. And I call it a donut, because you have the airplane in the middle and my display shows nothing but a little ring of reflectivity when you know there's a lot of rain around you. So I would say that we still are getting a lot of value, but maybe not as much value as we used to with the old C-band antenna that we had on the P3s. But we manage it because we have the nose radar and we have other abilities to evaluate what's outside of the eye wall.
Oh, fascinating. What's your time range? How long can you be in the air with the P3s? I know I've been asked that before, and I remember, but I want to hear it from someone that actually has to use it.
If you ask the crew, sometimes it's too long when you're, you know, getting bounced around for 4 hours, 4.5 hours are in storm environment. But really, the aircraft itself, we can pull off a 9 to 10 hour mission out there, but we'll usually only fly those when the storm is, say, really, really far away. Right about that 4 to 5 hour point in the storm environment is when you start kind of feeling the effects. And we always talk about safety of flight, right? And so we want to do it safely. And the moment you start feeling that fatigue or you start feeling the factor, we want to kind of move forward. And usually that kind of hits at that 5 hour mark. So we can fly 9 hours, but typically if maybe the storm's an hour away from here, we'll spend 4 or 5 hours in the storm, 1 hour transit. So it comes out typically between 6 and 8 hours of a normal mission.
Yeah, and I can gather from looking at how the choreography works that the planning probably through the Karka folks are such that when you have one that's approaching landfall, you want constant surveillance. So they're choreographing flights coming in and out of there, so you don't have to spend all that much time.
Sure,
Anyway.
and we have forward operating locations as well. So we'll go to St. Croix, Barbados, Bermuda, Aruba. I know this is really hard to hear that we have to go to these beautiful desert islands, you know, and go to resorts, but it does allow us to get forward operation. We can fly all the way to the Central Atlantic Ocean, you know, 3 hours out, basically right smack between Barbados and Cabo Verde. And we've operated out of Hawaii, we operate out of Costa Rica, so we have a lot of options to be able to get the aircraft closer, so we're not flying those long endurance missions. But it's you know, the schedule gets tough at times, you know, when we're going back to back to back to back to back, but you get in the flow of it.
Yeah, the Navy frowned on us using Barbados. They wanted us to stay at Rosie Roads in Puerto Rico.
That's logic. We like Barbados. We do like Barbados, and we have a great relationship with Barbados to be able to operate out of there and get the lodging, and we've operated even some science experiments out of there besides Hurricane. So it's been a really great island for us to operate from.
Yeah, they have that. They have a Caribbean Institute of Meteorology where it's a college. They teach meteorology, and they gain so much information and access to scientists during BOMEX back in the 1960s.
Yeah, BOMEX.
Actually operated out of there. So there was scientists there for the whole season. And ever since then, we've been welcome there. It's great. Yeah.
And HRD had a research project called Magpie with the Navy. Just this past summer, we supported kind of flying the Saharan air layer gradients as they're kind of coming across the Atlantic, measuring the boundary layer heights, how boundary layer is kind of varying the deep convection and the development of waves. So it was a really kind of exciting program. We also flew some island wake vortices. So you get those really strong trade easterlies and you get these wake vortices on the other side of the island. So it was pretty cool flying. It wasn't storm flying, but it was really cool flying and really important to understand, you know, easterly wave activity out there.
So do you have instruments on the plane that assess aerosol content?
Yeah, so for aerosols, we don't do any remote sensing of aerosols, although I think there's a lot of opportunities in the future to do that, particularly since we're bringing in some Gulfstream 550s, some brand new ones, some data ports. So I think there's some chances in the future potentially to do more remote sensing of aerosols. All we got in the P3s is mostly in situ, so we've got some cloud physics probes, but those same probes not only measure cloud particles, but they also will measure those sort of larger aerosol particles as well, like the dust. So we did have those installed, and we actually did some spirals of going from the clean boundary layer, only a couple hundred feet above the ocean, going through the base of the dust layer, the sow layer, and then going all the way up through it, because we can get to about 23,000 feet or so. So it's pretty cool. We're just doing like we call it microphysics spiral, just measuring all that dust. Yeah. And we do this in storms as well to measure cloud and precip particles.
Yeah, you could call yourself the big drop sun.
We are. The airplane's an instrument. The whole airplane is an instrument as well.
Tim, what you got for me?
One question coming in from online, just asking about the range of the Doppler or the tail. What is the tail Doppler? How far out can you see with it?
Yeah, the tail Doppler in kind of light rain conditions gets to about 50 kilometers or about 35 nautical miles. It kind of drops a little bit when you get into some of the heavier rain. But in a 4 mile eye, like a Hurricane Milton had at one point we were flying, or an 8 mile eye, every time we pass through, we have enough swath to see through it. So we're seeing about 30 miles on either side of the aircraft, which is a pretty large swath. That's you know, about a degree. So it's large enough. And in terms of the multi-mode radar, the belly radar that looks all around the aircraft, we can get to about 80 miles reliably with that radar, again, barring any heavy rain that might attenuate the signal. And we have that other mode, that SAR mode, that synthetic aperture radar mode, where we can kind of see a little bit further. I mean, when we're about 100 miles from the storm, I'm already on that SAR mode looking for the center, because I can get kind of through that rain and get a mark at that center and make sure I'm geographically, kind of geometrically heading towards the center of the storm.
We're watching some of the video from one of the flights now, and that's just which one was this? Is this the one that we all saw at some point after the storm?
Yeah, it's Milton. I mean, Milton was very aggressive, and I know there's been a lot of video of some bouncing around. Our AVAPS person who releases the dropsons, and they were back there. They got a pretty good ride. I always said the turbulence, your measure of turbulence is how much you have to clean the airplane, right? So we have a galley, we got coffee, we got stuff in the back, and if you're cleaning that after a pass in the eye, you found yourself at 8 or 9 out of 10 on turbulence scale, and they got that. They got one of those in Milton.
I would guess this is not something you're going to say 8 to 12 on, but how many storms have you flown into? And I'm guessing you know exactly how many.
I actually did look for a previous interview recently. I've got 20. This is my 26th hurricane. Was Raphael, the recent one. Probably another 15, 20 tropical storms. But we do measures. The measures for us is actually the number of hurricane eye wall penetrations. We call them pennies. So that means you got to going into the eye and then out of the eye. That's one. And so I've got, I think, about 210, 215 of them. And that's a decent amount. But we keep an official record. And actually, for the purpose of the pilots, the number of times we go through the eye wall and go through the storm is important for them, because they actually get qualified and certified based on those eye wall penetrations. So we actually do have to keep a pretty accurate count for them, the number of times we go through a storm.
So does anything still surprise you when you go in? Has there been in a storm going, holy crap, I didn't expect that?
Well, sub 900 definitely surprised me. We briefed that morning before we went out. We had been watching the Air Force flying. We had been watching their fixes come in, and the other P3 crew had been in previously, and they were seeing 936 down to 930, 925, 920, 915. It was just plummeting. And I briefed maybe we'd see 905, 906, never expecting to go in the storm and seeing what we ended up extrapting. We extract down to 894. I know our fix came in about 897 with the drops on. So that was my first time I've been surprised in a little while. But I say, like, again, 75% of storms I'm probably not going to remember. You start flying a lot of storms, not all of them very memorable, but then there's a smaller percentage like a Milton or a Dorian or an Irma, where whether it's a turbulence or the view or the science that really kind of keeps it in your memory.
That's what surprises you. What scares you?
I would say I've never been scared. I get that question a lot. Like, you ever been scared? I don't get scared for flights because I trust our crew. I trust our maintenance team. We work very hard on our what we call crew resource management. It's our ability to communicate with each other, be open when we're uncomfortable, identify weird noises and sounds, address issues, address emergencies. I trust in everybody, but it's not that I don't get nervous. I do get nervous, and before a lot of the flights. And Milton, I asked the crew, they were as nervous as they've ever seen me, just because that element of the unknown of, well, the storm's changing, the pressure's plummeting. What are we going to experience? And at that point, for me, it's always, let's just take it pass by pass. Let's see the first pass. How did we get through the first pass? Do we think that the airplane got beat up? And then we'll go to the second pass and the third pass. So I get nervous. I get a little anxious on the airplane, but it's a good one because it kind of keeps us focused on what we got to do. Because at the end of the day, the data is critical for the forecast. It's critical for the public advisories. And we'll be uncomfortable in order to collect the data for sure.
Let's take the midpoint break. This is fascinating. I love this conversation. Let's take our midpoint break and get our tropical update. First, let's thank the sponsors who are here week in and week out, been here all season long. USAA, the South Padre Island Convention and Visitors Bureau, the Weather Company, Weather Call, and Weather Boy, all part of what we do here. We appreciate what they do. Everybody has a unique role in NTWC and NTWC Plus, and we appreciate them for what they do and appreciate their support as we head into 2025. Okay, Bill, we've been talking about the goings on in the tropics as we speak, that you might have cruised into the beginning of something. Talk about where we are now.
Okay, but first I want to ask you a question. Since I wasn't around for it, how was the surf from Raphael down there?
Here, it kicked up pretty good. The surfers were happy. It was a little washing machine for them, but not initially these smooth swells. But at one point, it was the water was up to the dunes. There were coastal flood advisories all weekend. The county beaches were closed because the water was so high for a storm that stayed, obviously well offshore. It got relatively close enough that if it was August, we'd be going. But because it's November and currents are there, and it fell apart. But yeah, it was definitely active.
Yeah, I remember a surfer once saying, "If could you just stall one in the middle of the Gulf for a week, and we'll actually get big waves in Galveston."
Exactly. All the surfers I knew were headed to the coast this over the weekend.
Yeah. Okay. Well, so much for the past. Get my view of the future, and Jay-Z, feel free to correct me if I'm off the beaten path. Okay. You see this okay, Tim?
Yes, sir.
Okay. Yeah, we didn't dry run it, so flying without a net. It's the current outlook. It's in the 90%. They're almost certain it's going to form, as are the models. Centered over the warmest water in the basin right now, which is the Caribbean Sea, which is still running, if not at record, certainly above normal. So think about the oceanographic type conditions as being more related to what you'd have in early October rather than early in November. And that might explain why it's not that surprising to see a development down here in November. The current observations down there support there's actually some broad cyclonic flow across the entire Western Caribbean in the surface obs right now. The X there on the previous outlook is somewhere south of Jamaica in here, and I'm sure that's based on some satellite analysis. And I'll give us an update. So the NOAA folks have their meso sector, so we get the 1 minute shots of the developing convection south of Jamaica. And just like I saw earlier today, I'd be hard pressed to pinpoint, given all the cloud cover and the various motions I see. We'll wait and see what the hurricane hunters find a little later on in that region. A little broader scale of it, looking at the IR picture here, you can see the cloud tops moving from west to east, well to the north of the storm, to the south, out to the east, to the west, and then the northwest, which is indicative of a well-developed anticyclone aloft and good outflow. So you've got obviously plenty of unstable air with all these thunderstorms. You've got outflow, you got warm ocean below. I have no reason to believe that we won't have a significant storm in the next few days at the most as this thing evolves going forward. Speaking of the Recon, this was what was put out yesterday. We should be having a flight en route probably about now. A low-level invest, and then the word fix in there means they think it'll be a storm by then, and they'll be in the routine fixes we make on a named storm. And as Jay-Z pointed out, probably going to be a busy weekend. Tour Berg's interesting visualizations I like sometimes to show what's going on with the storm. And this was from the ensembles, and they're very way I would interpret it is where it looks like a fur ball coughed up by my cat down here. There's plenty of agreement that there's not much variation on the ensembles in the near term, and then it kind of diverges widely anywhere from the Yucatan to Western Cuba. If it survives all that and gets in the Gulf, there's a frontal system that'll approach and it'll eventually do a quick acceleration to the northeast. Way out in we don't know land as far as exactly how it'll go. Just a couple of shots on the model, starting with next Tuesday. The GFS and European both had a hurricane off the Yucatan at this time frame. There's an occluding glow in the westerlies over the central plains and a front probably down into Texas at that point. And the ECMWF parks it down in there and basically cuts off a low aloft further to the west, and that allows for the model to think that the storm will go near Tampa of all places. I'll be in Clearwater Beach that time, so it's that might be something to watch out for. And they've kind of flip-flopped. Earlier it was the GFS that was further north, earlier runs. Well, now the GFS, same time frame, it cuts off the low much further east and drives a very strong shot of cold, dry westerly. Oops, watch what I click. Down into the Gulf of Mexico and shoots the storm almost straight to the east over extreme South Florida. Again, as you really saw, more importantly in the ensembles, is there's no real consensus at that far out in time that you can hang your hat on. Elsewhere, we got a rapid intensifying typhoon. It went from, I think it's gained 40 knots in the last 6 hours on the JTWC forecast in there, and a couple of storm shades. I don't think Morgerman went for this one, but James Reynolds is on the northeast coast of Luzon, which is the point over here, and the current forecast from JTWC has the center of the eye clipping that point, that peninsula out there with the impacts in there, and we'll see what James has to report as time goes on. Tim, you want to take it for a second while I wet my lips?
Absolutely, you got it. So, it's interesting. Here we are, mid-November. We're not done yet. We're getting up to the numbers that were forecast. We may not make it to that total number of named storms, but we probably have made it to the number of hurricanes and major hurricanes. So, overall, with the exception of that lull in September, things have pretty much lived up to expectations. So, absolutely. Jay-Z, one of the questions came in from online was about flying in Rafael over the western tip of Cuba. And how often is flight over land even considered? And how often do you do that?
We definitely do it as needed. We have a lot of policies that help us stay safe, right? So we have an overland policy that tells us what altitudes we have to be at when we're flying over land, and it's tricky because landfall, you can get some really nasty weather. You get those almost supercellular onshore bands, and we're not going to put the airplane anywhere near those, and we're certainly going to keep our distance. The western tip of Cuba, we were actually able to. I was the flight director on the mission we flew over Cuba. The eye basically was centered, and every pass we did was almost completely centered over it. And at that point, we're really still trying to collect that TDR data. It gets a little tricky in the quality controlling of the Doppler radar data when we're over land, but we do fly over Cuba, we do fly over the Yucatan as needed, and it also kind of depends on diplomatic clearances and such as well. So we work hard to ensure that we can get airspace, be able to work in international airspace in other countries, and we've worked with Cuba to allow that to happen. And we really appreciate that because it gets us without too many limits, getting the data around the island and around Mexico. And certainly these are storms that are not only impacting us, but it's impacting them as well. And we're very conscious of that.
Interesting. Okay, Bill, jump back in.
Yeah, I'd be on the other end of that, trying to make sure. People were surprised when I told them we actually had relatively little trouble getting clearances, especially for the NOAA planes to fly in Cuban airspace. Some of the other countries were much more problematic, which makes sense to me. But I get questioned every now and then by national security folks up in Washington. Why are you flying over Cuba? And I said, well, the data over Cuba impacts what happens to Florida, and then they calm down on that. Do you get involved in the atmospheric river flights? I noticed on the bottom of the POD that they had your first of the atmospheric river missions scheduled.
Yeah, it seems like hurricane season's blended atmospheric rivers, and that's just as important of a project. Obviously, we could see the amount of effects that's occurred in the west coast of the United States for rainfall, snowfall, wind, waves. The coastal erosion, and we do support that. So the Gulf Stream, the G4 high altitude jet that we fly, We tend to deploy that every season out of Hawaii for at least a few months during the wintertime. And the idea there is you want to forecast it better, right? So we're trying to get the airplane and NCEP's trying to get the aircraft out there while the storm's over the Pacific, the middle of the Pacific, assuming that 2 days later is when you're going to start seeing the hazards, right, him back to the U.S. So we'll operate the G4 out of Hawaii and fly those storms consecutively and basically as they come over those few months. So we're planning to deploy the G4 in January out to Honolulu and fly basically into March. The P3 hasn't yet gotten involved in that recently. It used to do some winter storm reconnaissance. But right now it's primarily the G4 dropping SONs and collecting some of that TDR data as well.
Yeah, I think the 53rd supports that a lot.
They do a lot more support. They have a lot more operating locations as well. And this time of year, it's tough because you're in the shoulder of the hurricane season. You're kind of in the entering shoulder of the AR season. So I can't imagine the decision makers have to decide where they throw some of the assets when you got a hurricane in the Caribbean, but you also have a potential high impact AR. Making landfall on the West Coast.
So you're getting two upgraded Gulfstreams. So you're going to keep the G4 or is it going to be retired?
The plan will be to retire the G4. So we are planning to bring in a Gulfstream 550 shortly. And that aircraft, I always said the G4 to me, it's a great airplane. It's absolutely a great airplane. It really expanded our capability to fly surveillance and do long duration missions, high altitude. But our plans for the 550 are very exciting. We're hoping to have more hard points. That's where you can install instrumentation. We're planning to have 2 nadir windows. Literally, it's a hole in the bottom of the airplane that you can fill with an instrument. So we can start doing some of that sort of higher altitude remote sensing. I mean, I'm very excited. I said like the G4 is kind of a first grade science experiment. This is going to be more like a PhD or a master's level aircraft. We're going to do a lot more with it. And I know we're announcing that, I think it's been announced that the second 550 is potentially in our future as well. Because think about AR, it's in atmospheric rivers. You want to fly maybe out of Japan. You want to fly even further in the West Coast, even before these become factors in the U.S. or even during hurricane season, right? Some of those troughs that are entering the West Coast are the same things that are going to pick up hurricanes, downstream. So a lot of exciting opportunities as we kind of expand our capabilities here in the future.
Yeah, I like the idea too, because you could broaden the area you cover in advance of a hurricane,
Exactly.
see if it makes a difference.
Exactly.
Now, the C-130s, I'm used to what the Air Force have, other than the workstation for the drop wind son and the meteorologist. It still looks like a garbage hauler. Are they going to totally reconfigure the innards on the C-130 for the NOAA planes?
Yeah, we did have that announcement that we're replacing our P3s with C-130J Hercules, probably top of the decade, 2030 is the hope. And pretty, not to say the basic aircraft in the Air Force Reserve Hurricane Hunters, but they don't have the TDR, they don't have the MMR. We try to fly these things as scientific laboratories, and our hope is to remain that capability of making this thing, bring all these instruments on board, adapt to different kind of projects, air chemistry, hurricanes, atmospheric rivers, right? We've done sea ice experiments on the P3. And so there's a lot of exciting science. We want that capability. So we're going to work with teams here to figure out how we can adapt these new C-130s. They're going to be brand new, which is great. But we're going to try to figure out how to make it work. How do we get a Doppler radar on board the C-130? It doesn't go in the tail like it does in the P3. It's a different tail. Same with MMR. This is a high wing aircraft, whereas the P3 is a low wing. So you're closer to the ground with the C-130. So there's a lot of challenges coming up. It's certainly something we got to get over, but we're going to work hard on making these scientific laboratories as well, because that's our expectation at NOAA, is to maintain a great scientific platform.
I think there's a huge advantage to go under the C-130 in that remote sensing capabilities that you develop that work on the NOAA plane. It'll probably be easier to get through all the red tape to incorporate it on the Air Force planes. Yeah,
that's right. It's a pipeline, right? We've always talked about that pipeline. When we fly a research instrument that's going to help us maybe measure wind or rain better, or surface winds, waves better. The Air Force Hurricane Hunters, they're interested in as well, because they have more aircraft. They actually do a lot more operating in storms than we do. So if we can create that pipeline, maybe we can kind of expand that capability. We we support operations, but we're very much about developing the new technologies, and we welcome scientists to come on board and test their instrumentation. It's one of the exciting parts of the job as a rearesearcher, is bringing a new instrument on the airplane and seeing the data.
Yeah, I would find that very cool. The lost my train of thought there. I imagine it's, you know, just like cars they no longer make, since P3s are history now in the Navy world. Are you finding it tough to maintain the parts you need for the plane, or is that still okay?
It does get challenging. The number of Navy P3s flying are, I think, probably on one hand. I don't know for sure, but it certainly is getting hard to find the parts. And the great part about this facility is we have a great team of maintenance, a great maintenance team, and we also have a sheet metal shop. We got a paint shop. We can actually manufacture things in-house here to maintain the aircraft. But if you walk on the P3 right now, and you were on it in 1975 when they came around, it's almost going to feel the exact same. The interior is the same. I hesitate to say the smell's probably the same, with just maybe 50 years of maybe some air sickness and sweat. It's just hot. It gets hot on the airplane. It's rugged. It's a really rugged airplane. We maintain them at the highest level, and we have a lot of faith in the aircraft. But it's hard to do it. And fortunate, you know, we've been able to maintain the aircraft well, and we've got new wings. We got new engines a number of years ago. The aircraft were more or less refurbished, new avionics. And they're going to get us through the end of the decade, and we're really excited. And we're, in a way, kind of sad to also moving away, because they've just been the workhorses of some really excellent science and really excellent advancements. And they've been outstanding aircraft. And the C-130 will be very different for us, so we're going to adapt. We're going to have to figure out how to fly it and what the missions are going to look like, and it's going to feel different. And we're going to work on that over the next few years of making that airplane work for us the same as it did the P3s.
Yeah, you're right about the I don't know about the smells. My sense of smell's garbage anyway, but
we get people who get triggered by the smell
yeah,
of the P3.
I climbed on that thing for the first Hurricane Awareness Tour when I was director, and everything back in the tube is different. But when you got to the cockpit, I said there, oh my God, it looks exactly like the P3Bs that the Navy was flying Hurricanes with. And the galley was the same in the tail, which made it really tough to get you a cup of coffee in flight, flip-flopping around like that.
I always would say that the coffee pot is well seasoned. So it's well seasoned. It's good coffee. It's a little sludgy at times, depending on who makes it. But that's got to keep going.
We used the large styrofoam cups, and you weren't allowed to put more than a third of it full with coffee, because you got tired of us coffee walking back up to your workstation.
We use lids now, but it is a little disappointing when you're in the middle of an eye wall and you want a little coffee and your coffee spilled on you.
Yeah, no kidding.
You get a little angry.
Of course, it was even worse back then because we smoked on the plane. Looked like the inside of a bar most of the time. Blue haze all around the place. More stories, but where is your workstation on the aircraft as flight director?
Yeah, the flight director station is, if you're going up the tube, the ladder's in the back, you're walking tube, you're going to see a lot of science stations going forward. So that's where scientists can monitor data. We got them. They have internet capability and stuff. And then as you move forward to the airplane, just before you get into the cockpit, you'll, on the right side, looking into the cockpit, you'll see the navigator, and the left is the flight director seat. And it's a pretty comfy seat. We got a lot of space. I got a bubble window, so I can look out the window and literally look out the window in a way, right? Because it's bummed out from the aircraft, so we can actually see the ocean. And it's a pretty cool view when you're in a stadium. But yeah, we're forward left, just behind the cockpit, and we're kind of part of that front end. I call it this kind of the circle of safety, because we're all talking to one another. The navigator, myself, the Hurricane aircraft commander, the pilot flying, the flight engineer. We're all talking to one another, communicating about what we're seeing, where we're going, how we're going to get there, things that may be happening that are concerned. You know, is something going on with the engines, that kind of sort of thing. So it's that kind of circle of safety, and allows us to be up there isolated and talk a lot while we're doing the eye wall work.
Yeah, that other than a few minor differences, it hasn't really changed that much. My
still up front.
My station was the same as yours. The right side was a radio operator, because that was our bandwidth.
Right.
And
I would
the navigator
garner
operator were in the tube and right over the wing.
It's going to look more modern if you saw it now. We've got we got a couple computer displays. We've got iPads on the aircraft now to repeat some of the imagery and data flow and stuff like that. So it's been modernized a little bit. We don't have those old TV screens, those old tiny TV Panasonics anymore.
Good.
We upgraded those.
Well, next time the hat's down this way, I'll have to sneak over early and
Absolutely.
chat with everybody on it. It's an amazing bird. Tim.
I love the then and now conversation. This is great. What was, Bill, when were you flying into the storms, Bill?
The 72 and 73 seasons.
And that's 50.
Other than Agnes, there's not a single storm on that list that anybody would remember.
But Agnes was significant. Obviously, it was one of the big inland flood storms after the fact. So yeah. So I love the conversation of what was 50 years ago and how we're still doing the same thing, almost the same way, but with brand new technology. I guess that's the change. I would guess.
Yeah, the Recon pattern, the hourglass, figure 4, alpha, whatever you want to call it, is virtually unchanged. Other than I don't think in a hurricane anymore anyone flies them down below the clouds like we did.
We do not do that for sure. There will be no 1,500 foot flying in hurricanes anymore, just given the previous incidents. And yeah, we don't fly anywhere below 8,000 pressure altitude in hurricanes, and so pressure is lower. So we are descending a little bit. So your actual altitude of the ground is lower when you're in the center. So in like Milton, for example.
The graph that Tropical Tidbits shows, you can actually see that dip in there. I show people, especially school kids, get a wow factor out of that.
Yeah, in Milton, we started at 10,000. We ended up at 7,500 feet above the ground. So we lost 2,500 feet. And you feel it. In a Cat 5, you know the airplane's pitch nose down. We're crabbed into the wind. I mean, think about when we're flying, we're kind of nose down angle going in and nosed up and rolling heading out. It's something I don't think people appreciate about doing the Recon. We're not just flying one altitude. We actually have to manipulate the aircraft and actually follow that pressure surface descending into the eye. And the stronger it is, the more you're descending. And you definitely feel it. And you're crabbed. So you're actually pointing, in a Cat 5, you're pointing 45 degrees away from your actual ground track. So if we're heading west, we're actually pointing southwest while the airplane's going west.
Yeah. There's an old movie out there in a Super Connie back in the early 60s in a really strong storm. And the cameraman was in the cockpit, and you could really, here's the wind in the ocean, and the plane looks like it's at least 45-degree angle on that. But
we have a video from Patricia, which was sub 880. And the nose camera showed when they went into the eye and they came out of the eye wall in the eye, the nose is pointing at the ocean. Like you could see the ocean surface, see the waves. It's remarkable. I would imagine also maybe a little bit discomforting to be pointing at the ocean when you go into the eye of a Cat 5.
Yeah. You can only improve on that by flying into a tornado, but I don't recommend it.
We will not do that. We have done tornado projects, and we have seen tornadoes within a few miles of the P3, and that also is a little uncomfortable, but it's, we do the science, and we'll push where we need to. But we have seen tornadoes from the P3.
Yeah, I think you guys were involved in one of the Vortex campaigns.
Vortex Southeast.
I just don't think that's a cool thing to do. Hail gets kind of big, and it doesn't take big hail to tear up the nose of an airplane.
We get enough hail in hurricanes. Like we do get grapple. We get small to large grapple in Milton. It's audible too. You can hear it, even if as loud as 4 motors are inside the airplane, and the wind, the rain hitting you. You know when you hit grapple, and we definitely hit some grapple in Milton, and we're below the freezing level. We're well below. Freezing level's up at 15,000, 16,000 feet. We're down at 8,000 getting grapple.
Wow. Does it tear up the paint?
Yeah, we kind of walk away from the airplane pretty quickly when we get on the ground and the maintenance crew comes up.
Yeah.
Sorry, gotta go. Crew rest. Yeah, it takes the pain a little bit.
The maintenance crew never gets enough hurrahs. How many staff does AOC have to maintain these aircraft?
Just on the P3s alone, I think we've got over 10. We've got 2 crew chiefs. We've got a number of people, and they're experts, right? Some of them are going to be working on the outer surfaces, sheet metals, making some of the parts for the aircraft. We've got avionics techs. We've got engine techs. We've got people for every component of the airplane, and most of them have all worked on turboprop aircraft, if not the P3 itself. So we got a lot of crew, and got to keep in mind, this facility is not just the P3 G4. We have we've got Twin Otters and we've got King Airs as well that fly all sorts of other projects. In fact, the P3s and the G4 represent a very small number of hours compared to our light aircraft, the Twin Otters and the King Airs that fly year round. And it takes a lot of maintenance teams. They're always out. If you have one of each aircraft in the hangar, it's a surprise. They're very busy airplanes.
Yeah, and you don't have the luxury. We always had a plane they called the Hangar Queen that they'd steal parts from to keep the other 5 flying. You can't.
Yeah, no 44 P3's gone.
Yeah,
we took the parts from it.
Yeah.
What does happen to a retired plane when you get ready to retire a plane? Where does it go? What's it do?
Davis
Sorry, Bill.
I'm sorry. They used to send them out to the desert in Arizona.
I think they make them available to the GSA, and somebody can purchase. If they would really love an old G4, maybe soon they'll be able to do that.
Oh, yeah.
Well, all the parts, all the meteorological parts are taken out of them, I'm sure. But
yeah,
a cool display at the Hurricane Center or something, that go see one of the planes. You can go see it anytime or somewhere. I don't know where, but something like that.
Well, our hope is that the P3s will not go into the desert. Our hope is that they will end up in museums and be available to the public, because they are pieces of history. And, you know, as we as meteorologists know the history of the P3s and appreciate what they've done over the years. But I think getting them out in the public is fantastic, because it really talks to the kind of advancements we've made. And these P3s are historical aircraft, and they deserve, we hope, in a rightful place in a museum and available to the public to continue to see and understand.
That'd be great. Maybe we could find a donor that would sponsor a move to like the Smithsonian or something. That'd be cool.
Perfect. Well, guys, we're running up to the top of the hour. Any final thoughts, Jonathan, you want to add as we get to the end of the hour here on what you're doing, where you're headed, what's going on? Anything you want to add?
Well, we're hoping the hurricane season's coming to an end. Hopefully this thing will avoid mostly land and we'll end the season. But, you know, we're ready to support. We're always ready to support and get the data collection we need. And you know, plan is to probably go out Friday and start the data collection. And, you know, this, to me, it's a really exciting job. We certainly love what we do. And, you know, we talked about the hours, the amount of work you put in, and it can be exhausting, but, you know, we're here to serve and get the data for the scientists, for the Hurricane Center, for everyone around there who relies on this data. It's something we're very proud of. And that's what I want to maybe end with, is we're very proud to do this job. And it's an honor to be able to go fly in these aircraft and do the job.
Well, we do appreciate what you do, each and every one of us in this industry, because we couldn't do it without you. We couldn't do anything without you guys out there getting that data. Bill, any final thoughts today?
No, to me, it was very heartwarming to learn of all the continued advancement in how we do recon, and that there's some interesting stuff coming up for the even out years in the recon world. The only thing I can think to add is if you're short of volunteers for that atmospheric river job in Hawaii, this old guy will go do it.
We'll add you in the wait list, Bill, for the flight directing on the atmospheric river.
Somebody's got to do it. Well, gentlemen, thank you. Great program today. Jonathan, thanks for taking time to be with us. We appreciate your time and appreciate what you're doing. And be safe this weekend, you know, going out there again. We'll look forward to the data coming back. Bill, thanks as always. Love the insight. I think this was fascinating. Again, the then and now aspect of this, of where we were, what we were doing 50 years ago versus what we're doing today. A lot of the same things, maybe just in kind of a different way. So thanks, guys. Well, thank our sponsors who are part of this program each and every week. USAA. My gosh, thank you. And thank you for being part of all we do with the Storm Science Network, the parent company of the National Tropical Weather Conference. We appreciate you, USAA. Thank you. South Padre Island Convention and Visitors Bureau. We will be back there in April of 2025. We hope you'll join us there. Registration now open online, so look for that and sign up and come join us. The Weather Company, Weather Boy, and Weather Call, all part of NTWC Plus. We are taking the next couple of weeks off as we get to the end of the hurricane season, unless we have to do an emergency show next week with Sarah. Let's hope we don't have to do that. Then our next live program will be on December the 4th, and that will be a wrap-up of the 2024 hurricane season. We'll look back at all things that we went through this year, all the named storms, and kind of talk about all of it. So we'll do that on December the 4th. So until then, y'all take care. Have a great Wednesday, and we'll see you in a few weeks.